Hi guys, so today we are again reviewing a little bit more from geometry, and this is a unit I'm sure a lot of you guys remember because this is when you learned about SOHCAHTOA. So SOHCAHTOA was a way for us to remember what all of our different trig functions stood for. So what we're going to start with is the very first S stood for the trig function sine. And if you guys remember, all of these trig ratios were ratios of sides for different angles. So sine was the ratio of the opposite side of the angle over the hypotenuse. Alright, then we also had cosine. And cosine was the ratio of the adjacent side, so the side that is next to that angle over the hypotenuse. And then T stood for tangent, and tangent was the ratio of the opposite side, I'm just going to abbreviate them now, opposite over adjacent. Okay, so now that you guys are moving on to pre-cal, you guys are going to learn a little bit more trig functions that you've done before. So we're actually going to learn 3 new ones. And what these 3 functions are referred to, these are your reciprocal functions. So they're reciprocals because they are flipped. So sine has a reciprocal function that is called cosecant. Cosecant is abbreviated CSC. And cosecant has a ratio as well, but it's the same as sine, it's just flipped. So the ratio for cosecant is hypotenuse over opposite. So I take my sine ratio and I flip it. Okay, cosine has a reciprocal, and that reciprocal is secant. And secant is abbreviated SEC. So the reciprocal of cosine is secant, and that is hypotenuse over adjacent. And then you also have the reciprocal of tangent, which is cotangent. And cotangent is abbreviated COT. And cotangent is tangent flipped, so it is, oops, I put a T and that should be a C. It is adjacent over opposite. So you had SOHCAHTOA for your regular trig functions. For your inverse or your reciprocal trig functions, it's CHO, which is a little harder to remember. But the biggest mistake that people make is a lot of people will flip-flop cosecant and secant for which reciprocal it is. The easiest way probably to remember it is if you look, every pair of functions, sine and cosecant have one co. Cosine and secant have one co. Tangent and cotangent have one co. So each set has the word co one time. So if you have 2 co's or no co's, it can't work. Alright, so there are one co for each pair of reciprocals. Alright, so another way you might see this written, sine is equivalent to 1 over cosecant. And again, I'm still at a volleyball tournament in Allen. If you keep hearing random sounds in the background, sorry. You also could see that written as 1 over sine is equivalent to cosecant, because those are your reciprocals. Okay, so to start, we're just going to write a couple of these ratios. So the first ratio we're going to write is we're going to find the sine of angle E. Now remember, every time you find a trig ratio, a sine, cosine, you have to find it for a specific angle. It's going to change based on which angle it is. So the first thing I need to figure out, sine, if I use SOHCAHTOA, sine is the ratio of the opposite side over the hypotenuse. Alright, so I look at my picture, there's E, and the opposite is 6. My hypotenuse I don't know yet, but if I have 2 sides of a right triangle, it's not a special right triangle. I don't know what those angles are, so I can't use what we did yesterday. But if I know 2 sides of a right triangle, I can always use Pythagorean theorem. So I can do 6 squared plus 3 squared, and I'm going to end up that C is going to be the square root of 45. Now, yesterday I told you guys you could save yourself a little bit of work. You didn't have to rationalize the denominator. However, you do need to simplify radicals. And by simplify radicals, that's when there's a couple different ways you can do it. It's when you take out those perfect squares. And a lot of you guys learned it where you did the factor tree. So if I want to simplify the square root of 45, I'm going to break up 45 into different factors. So I've got 9 and 5, and then 9 breaks down into 3 and 3. Then I look at all the bottom numbers. There's a pair of 3's, so 3 goes on the outside of my square root. There's still a 5 that doesn't have a pair. Any numbers that don't have pairs stay in the inside. So the square root of 45 is actually 3 root 5 when I simplify it. So I'm going to use that to go back and write this ratio. So my opposite of e is 6, and my hypotenuse, I just figured out, is 3 square root of 5. And I'm almost done because I just need to simplify this. So I can simplify 6 and 3. So my final sign ratio is 2 over the square root of 5. Alright, now I can also write my cosine ratio. My cosine ratio for e, I'm going to do it the same way except cosine's adjacent over hypotenuse. So my adjacent to e, next to e, is, but not a hypotenuse, is 3. So my adjacent is 3. My hypotenuse I just solved for is 3 root 5. And if I have 3 divided by 3, sorry guys, still at a volleyball tournament, but if I have 3 over 3 and I reduce that, that's not going to make those 3's disappear. Okay, a lot of times when we simplify we have trouble, but remember 3 divided by 3 is 1. So I can't just make those 3's disappear and get the square root of 5 as an answer. What I have to remember, oops, I just made that move, did not mean to do that. What I have to remember when I simplify those 3's, I'm left with a 1 at the top. So this is actually 1 over the square root of 5. And that's my cosine ratio. Okay, we're going to do a couple more examples. So let's look at the sine ratio for angle C. So if I look at angle C, sine is still going to be my opposite over my hypotenuse, and I erased, we said our hypotenuse was 3 root 5. So my opposite from C, if I look at C, across from C is 3. So my opposite is 3, and my hypotenuse is still 3 root 5. And when I simplify that, I end up with 1 over the square root of 5. If you guys look, the cosine of E is actually the same thing as the sine of C. And we're actually going to talk about why that is a little bit more later. So the last two I want to look at are just two of the new functions. So we're going to look at cotangent. So cotangent is the reciprocal of tangent. So you can either find your tangent ratio and flip it, or just remember that cotangent, that cow, let me write that down there. Might be hard to remember, but there's my reciprocal functions. So cotangent is adjacent over opposite. So if I look at my adjacent to C, next to C is side 6. And then my opposite is the 3 side. And when I reduce that, I end up with a ratio of 2. And then finally, I have cosecant. And again, I can do this two ways. I can look to my ratio, and I can see that cosecant is hypotenuse over opposite. Or if I know that cosecant is 1 over sine, I already found the sine of E up here. So all I need to do is take the sine of E and flip it. So it's going to be the square root of 5 over 2. And I would get the same thing if I had done that as my hypotenuse over opposite and ended up reducing it. So you can do it either way if you've already found them. Alright, so for the last example, we're going to look at a little bit of a different question. So what this is telling me is, well, first of all, I want to let you guys know, I'm doing this on my iPad, and there are all those different little icons that you can use on your keyboard, from everything from food and sports to animals and smiley faces. However, there is not a single one of them that is a theta that I was able to find. So theta is the little circle with a little line through it. It's a lowercase Greek letter. So theta is you're gonna see very often. It stands for a missing angle. So the little hamburger is taking the place of theta. So what this says is that secant of theta is equal to 5 over 3, and we want to find cotangent of theta. Now you won't be given a calculator on this, so you can't actually use a calculator to evaluate what theta is. But we don't need a calculator actually to figure this out, because we're going to draw that triangle. So I know on this triangle, theta can be either two of these angles, so I'm going to make this bottom angle my theta. If I remember with my ratios, secant is the reciprocal of cosine, which means that secant is going to be, whoops, moved it again, my secant ratio is going to be hypotenuse over adjacent. So that means that my hypotenuse is going to be 5, and my adjacent side to the angle I picked as theta will be 3. So I'm going to fill in my triangle with a hypotenuse of 5 and an adjacent side of 3. Now I can use the Pythagorean theorem to find my missing side, and if you guys remember back from geometry, this is one of those Pythagorean triples, so it's a little bit faster. I know if I have a 3, 4, 5 right triangle. So now I need to find, using this picture, I need to find my cotangent ratio. Now it doesn't matter where you put theta as long as you don't move it. I need to keep theta where it is. So looking at theta where it currently is, I need to find the ratio of my adjacent side over my opposite side for the theta I currently have marked. So if I look at that picture, adjacent to theta is next to it, that's my 3. Opposite of theta, what's opposite from it is 4. So my cotangent ratio is 3 over 4.